Good morning, grade 11. Today, inshallah, we're going to start in section 1 of chapter 12. We're going to talk about types of mixture. So, here, once we talk about mixtures, okay, first of all, we need to know what the meaning of mixture. So, if I ask you guys what the difference between mixture and compound, so that is a very, very important question. We need to differentiate between compound and mixture just to understand what is the mixture and how it's different than compound. So first of all, we said that compound, regarding to what we studied in the first two quarters, okay, it's once there are two chemical substances or more are mixed together and then they combine chemically, which means there are new bonds formed between the substances or the atoms just rearranged and forming new bonds. So they lead to formation of new chemical substances or new sub products which have new chemical properties different than the others. In that case, we call this compound. For example, when hydrogen, which is gas, reacts with oxygen, which is also gas, to produce water. Okay, in this case, water is liquid. So here in that case, we're gonna find that water actually has different or completely different properties than oxygen alone and hydrogen alone. Also, once sodium, okay, reacts with chlorine. So sodium actually is a silvery shiny metal solid. Okay, that's react with chlorine, which is a green gas, which is poisonous. So once they combine together, they produce sodium chloride in ACl, which is a white solid, that table salt which we eat in our daily life. So here like this, that is a chemical reaction or chemical combination or the compound, okay? The results are compounds which are completely different than the reactants which produced. But in case of mixture, we said it's a physical combination. What is a physical combination? Physical combination means we just mix them, blend them, but actually they don't react. Like when we ask you to make a dish of salad, okay, in that case, we are gonna just mix some vegetables, some cucumber, tomatoes, carrots, blah, blah, blah. So you are gonna add this together. After adding them together, do they react together or do they combine to produce a new kind of vegetable? Actually not. Each one still keep its own properties, but they just mix it in one dish. And easily to separate them, you can separate them again. In that case, we call it mixture. So mixture is just a physical combination that doesn't result in formation of new substance, and each substance of the mixture keep its own properties as it is, no change in the properties of the mixture. So here that the big difference. For example, here in your textbook, as you can see, he asks you that when you just pick amount of soil, okay, you could find that soil easily. You could observe that it's a mixture because it's made of different sizes of sand, clay, gravels, blah blah blah. All these are the components of mixture, so you can distinguish by your naked eye its components easily. So that's it. But what do you think once you get okay a cup of milk? Okay, so what do you think? Milk is a mixture? I think most of you are going to say no, it's not a mixture because I can see a component. It's just one thing. Okay, actually not, because milk actually is made of some carbohydrates, lactose sugar, and some protein, some fats, blah blah. All these components are found in the milk, but you cannot see with your naked eye. Also, when you get okay the table salt, okay, and just dissolve it in water, so you're gonna get a salty water, okay. That is a kind of mixture, okay. Although you cannot see the salt after it's completely dissolved in water. So here we have two types of mixture. We have something called homogeneous mixture, and we have something called heterogeneous mixture. So here we have homogeneous mixture, okay. What homogeneous mixture? That the mixture that you cannot distinguish its component. You cannot differentiate its component. It seems to be one thing. It has one outlook or it has just one appearance. Okay, so in that case, I can find its component by naked eye or I can distinguish its component. While we have another type of mixture which is heterogeneous mixture. So heterogeneous mixture, it means the mixture which I can distinguish its components. I could see the difference. Like when you look to a dish of salad as we do, you could just easily know what are the components. Like picking up amount of soil, that's also a heterogeneous mixture. So like this, we have two main categories of mixtures, which are homogeneous mixture and heterogeneous mixture. Heterogeneous mixture, the mixture that you could distinguish its component, while homogeneous mixture, the one that you can't. Okay, so that's good here. In an alternative way, okay, or we could just sometimes some homogeneous mixture could be described as solutions. Okay, so what is solution? Solution is a type of mixture which is a homogeneous mixture, but in which here we could find that there is a substance like table salt, for example, like sugar, which is able to dissolve, or we call it soluble substance. So what is meant by soluble substance? That means a substance has ability to dissolve, okay, in another substance. So once you add the table salt or the sugar in a cup of water, it's gonna dissolve. In that case, we are gonna say that salt and sugar are soluble materials. They able to dissolve in water. So what actually the word or what does it mean the word dissolve it means? Okay, so to figure out the meaning of dissolve, okay, so let's look with me here. So simply if we got, okay, for example, sodium chloride is a table salt is made of sodium and chlorine. So we're gonna find that there are sodium ions found in uh, alternating with the alternating with chlorine ions. So like that. So the big one, okay, that's here the sodium and the small one H with the chlorine, and actually it's found in form of cube, the crystal shape, okay, of the table salt is cube. So imagine that we have plenty of these atoms arranged in that cube. So once you drop these in a cup of water, what will happen? Okay, simply here we know water is made of H2O. So H2O, that is the chemical structure of water, in which there is one oxygen atom bonded to two hydrogen atoms, okay, by covalent. But we remember that water is a polar compound in which oxygen carry a partially negative charge while hydrogen carry a partially positive charge. Just to remember why it's polar due to the different electronegativity between oxygen and the hydrogen. So let's remember what is electronegativity. We said that the ability of nucleus or the protons in the nucleus to attract the electrons of the bond. So because oxygen has positive 8 protons inside while hydrogen just have one, so oxygen is more able to attract the electrons toward itself. That's why it is partially negative while hydrogen is partially positive. In this here in the table salt, we find that sodium carry a positive charge, okay, while chlorine has a negative charge. So in that case, once we drop it in water, we're gonna find that the water molecule, the positive hydrogen, will be attracted toward to the negative chlorine, while other water molecule, the negative oxygen, will be attracted toward the positive, okay, toward the positive sodium. And due to the continuous movement of water molecules, they are gonna cut or separate these ions from each other, which means that this cube of salt will break down into smaller pieces and smaller pieces until they turn into separated ions that they are gonna just completely distributed between the spaces of water molecules. So here like this, that which is solubility or that is a dissolving process. So dissolving process or solubility means the breaking down of substance into small particles that could completely distribute or hide or just fill the spaces between the solvent or between the water, okay, molecules. So here like this, once the salt or the sugar completely break down and distribute among the particles of the water, in that case we call that this is a mixture and it's homogeneous because I cannot see the salt or the sugar anymore. And in that case, okay, we call that a solution. So solution, it's a kind of homogeneous mixture in which one substance dissolved completely or dissolved in the other substance. Okay. So here like this, as you can see, that's here after we adding table salt and water, you could find easily that the water molecules, and here they are the ions. Okay, the purple one represent the sodium, okay, sodium ions, while green one represents the chlorine. They completely distributed among or between the spaces of water molecules. In that case, they form a solution. So like here, we could say, or we could define solution one more time as a homogeneous mixture of two or more substances in a single phase. That means you just give one appearance, one outlook. Okay, I can distinguish its components. So what are the components of a solution? If I can distinguish the component, but still made of components, like for example, the solution of salty water, what is made of here again, easily it's made of water and salt, or sugary water, so water and sugar. So in that case, actually, you always are going to observe that any solution is made of two major components. One substance dissolves in another substance. So the substance which we dissolve, we call it solute. So what is solute? Solute, that the substance dissolved in solution, we call it a solute, okay? While solvent is the substance in which the solute dissolved. So again, we have two components, any solution. So simply we can say that solute plus solvent, they are going to produce solution, okay? So here, that is the components of solution. Solute, the substance that could or that dissolves in solvent. What is solvent? The substance which the solute dissolves in. So here like this, okay, we know the component. Any solution is made of solute and solvent. So here we're gonna find regarding to the amount of solute to the solvent or the ratio between solute and solvent, we have different concentration of solution. That means I could have solution with different concentration. For example, when you get a cup of water and you just add 1 spoon of sugar, it will be a sugary water, okay? But you are gonna find that the taste of sugar is not that strong as you add 2 spoons of sugar. So like this, by increasing the amount of solute in the solvent, you increase the concentration, okay, of the solute. So here that's represent the idea that why we have different concentration of different solutions being based on the amount of solute that was going to dissolve in a solvent, okay? So here like this, we know what are the components of any solution. Then we pass to the next part, which is types of solution. We have different types of solution, yes, depending on what we're getting to. We have different types of solution depending on the type of solvent and solute which we have. So actually, we are gonna find that we have many solutions that could exist in a gas, liquid, solid formation, okay, or solid state. So actually, the most common one, or that what we imagine that we have the solute is solid and that dissolves in a liquid which is a solvent. That's the common, okay, solution which we know, but actually we have different types of solution based on the state of the solid and solvent. So sometimes we could have gas, okay, solution, okay, like for example, okay, that's here oxygen could dissolve in nitrogen. Gas, liquid, like carbon dioxide dissolves in water. Liquid solution, like once alcohol dissolves in water. Liquid, solid, okay, like mercury, okay, and silver and tin, okay. So here, solid, liquid, like sugar in water or salt in water. Solid, like different alloys, okay. So we'll here that represent the idea. So let's take an example of the solid solution. For example, here, the alloy, you know, gold, okay, actually natural gold, okay, in nature, the normal gold actually is not that solid. It's somehow soft metal that could easily be bent by your hands or broken. So in that case, it will be hard, okay, just to make jewelry or something like this from. So to be able to make, for example, that ring, I cannot use only pure gold. So in that case, I need to mix the gold with other elements that provide it with more hardness. So we make a kind of alloy. Alloy just gold mixed with copper, some silver, okay, that make it a little bit harder, okay. So like this, I could use it making euros and like this. So this alloy, how we make this alloy? Simply, we get gold in molten form and copper also, and then we start to mix them together in certain ratio, okay, or in certain concentrations, as we said. So that's here actually which causes different parts, okay, of the gold. Sometimes you hear that we have gold that 21 carats, okay, 18, and so 24, okay. That depends about the ratio. The more the card, the higher number of carats of gold. That means the more gold that you have regarding to the other elements in the alloy. So that's here like this, guys. We know what is the different types of mixtures, okay, heterogeneous, homogeneous, and then we know what is a solution, component of solutions, and type of solution. That's our lesson for today. Thank you, guys.